Hey everybody, welcome back to Mr. Shahkar's Math Awesomeness show of cascading brilliance. Happy birthday to me, even though it's not my birthday, but happy birthday to me. So, here we go. I'm going to be going over more finding special products with polynomials. Who's excited? I'm excited. You're excited? You know it. Okay, so here we go. If we were going to start with just the basic idea of squaring polynomials, like if I have x plus let's go 7, and I'm going to square that. Oh yeah, the big mistake, the big no-no, and I'm going to do it in the big no-no color of magenta. It would look like this. This is the no-no. When people go like, well, I'll square the x, and I get x squared, and then I'll be like, and I'll square the 7, and I'll have 7 squared, which is 49, and that's the answer. That is not the answer. This is so wrong. So instead of being bathed in wrongness, let's go ahead and being bathed in glory. So here we go, starting with, if I look at this, the idea is that I can break it apart and go x plus 7 times x plus 7. It's the whole idea of squaring. Squaring is mean I multiply the same thing, I multiply it by itself. Okay, so x plus 7 times x plus 7. We know FOIL. It's going to be the FOIL, this firsts, so x times x gives me x squared. Okay, next I'm going to have first outers, then I have x times 7, which is 7x, inners, which is plus 7x, and lasts, which gives me 49. And then I can put together my like terms. In this case, my like terms are 7x and 7x, so I end up with x squared plus 14x plus 49. Okay, now there is a special trick that goes along with squaring a binomial, okay, which can totally speed things up, but if you like just multiplying it all out in the FOIL pattern, you can do that. I accept that. But if you want to save a little time, there's a pattern that actually arises, which is this. If I have a plus b, and I square this, the pattern that will come out of this will be a squared, b squared as well, but in between will be 2 times a times b. What are you talking about? So let me explain this out. Let's pretend that this was a over here and that this was b. We ended up with our a squared, which was x squared. We also ended up with our b squared, okay, which was 7 squared, which is 49. And then I keep talking about this 2 times a times b. What are you talking about? Let me explain it. The idea is, if this is a times b would be 7x. Oh look, I've got a 7x. Wait a second, I've got 2 of them. 2 7x's, therefore 2 times a times b would be 14x. Oh man, but that can't possibly work over and over again. Really? Let me just double check. So if I go ahead and did another example, and I know that's what you were just asking about, you're like, Mom, I wish you did another example. And I said, you can tell word to your mother, I'm about to do another example. So here if I'm looking at, let's say it's y plus 4, because I know that's what we're going to go with, and then I'm going to square that. Okay, if I FOIL that, that's going to be y plus 4 times y plus 4. I'm just proving it first. My firsts are going to give me y squared. My outers are going to give me plus 4y. My inners are going to give me plus 4y. And my lasts are going to give me 4 times 4 is 16. So wait a second. This can't possibly be following the pattern of a and b, a squared, and then b squared is 16, and then a times b, which would be 4y times 2, 2ab. That can't possibly give us, there's 2 ab's, oh my gosh, so therefore I get y squared plus 8y plus 16. Holy moly, that follows the pattern. And now you have just become algebra geniuses, and you are capable of saving the world. So that is your homework for the next week, is to save the world. In the meantime, let's go ahead and solve I'm having a good time. I hope you are too. So in the meantime, let's go ahead and solve some more of these. So instead of adding them, what if I threw at you some crazy numbers like, I don't know, 2x minus, let's go 5. 2x minus 5, and we square that business. 2x minus 5, can you possibly do that? Oh, I can. Are you ready to see this? Yes, you are. Let's go. So if I was going to FOIL this, all right, I'd say 2x minus 5 times 2x minus 5. So if we're ready for this, I FOIL. Firsts would give me 2x times 2x, which is going to give me 4x squared. Then I go outers, which is 2x times negative 5. That's a negative 5 monomial, okay? And so that would give me negative 10x. Just so it's clear, it's 2 times negative 5 is negative 10x, okay? And then I have my inners, which are negative 5 times 2x. Oh my gosh, that again is negative 10x. And then I have negative 5 times negative 5. What do I get when I get positive 5 times, I'm sorry, negative 5 times negative 5? Two negatives make a positive 25. So excited about that. Now let's put together my like terms. Oh my goodness, I've got like terms. I end up with 4x squared minus 20x plus 25. I wonder if there is a pattern that applies for subtracting, okay? When I have a binomial that is subtracting and squared. So there is actually a pattern, and are you excited to learn about it? Yes, Mr. Shahkar. Good, I'm so glad that you responded to that. I love a class that responds when I ask questions. So here we go. That's going to look like a minus b squared will end up this way. It's going to end up with a squared. It's going to end up with a b squared, because negative times a negative makes a positive. But in between, is going to be minus 2ab plus b squared. What are you saying? So let me show you from the previous example. Here I have my a, this is my a portion, this is my b portion. My a will, oops, can you see, right, bam, right there. So I have my a squared, okay? So 2x squared is 2x times 2x gives me 4x squared, okay? That's my a squared. Second part is my b, which is negative 5. Negative 5 squared is a positive 25. Oh my goodness, so there's my b squared. And then I have negative 2ab. So in that case, I have a, here's a ab, and here's an ab, all right? And so there's two of them, right? So it ends up being a negative 2ab, okay? So just to clarify that, if I were going to solve this problem, another problem like this out, let's say I had, I don't know, let's go 6x minus, I don't know, let's go 3. Let's go with that, and let's square that, okay? So it would look like this. I can look at the a squared portion, which would give me 36x squared. The b squared portion would give me a positive 9. And then the negative 2ab would give me negative, what am I talking about again? Oh, negative 3 times 6 times 2. So negative 3 times 6 is 18 times 2 is going to give me 36. I really didn't see that one coming, but that is okay. It's good to have surprises in life. So it actually would end up to be negative 36x squared minus 36x plus 9. If you wanted to see that foiled out, yeah, we do! I didn't realize that you were so excited, so let's go ahead and do it. So it'd be 6x minus 3 times 6x minus 3, because that's what I'm just foiling this out. And 6x times 6x is 36x squared. And then that's my firsts. And then my outers would be negative 18x. And then my inners would give me negative 18x. And then my last, negative 3 times negative 3, is plus 9. And so then I would put together my like terms here. And that would give me 36x squared minus 36x plus 9. And there you go. Those are some special products when squares of binomials, okay? So those are squares of binomials. Who's excited? You're excited. I'm excited. It's a really good time. Everybody's having a great day. So happy birthday to everybody out there. And this is Mr. Shahkar signing off. And have a great day. Enjoy your weekend. Yeehaw. I don't know why I'm still talking. Peace, bye.